Hello, everyone. Welcome to the session Programming in C. And we are going to basically discuss about the question and answer for the previous year papers. So this is welcome to the session Programming in C. And we are going to Okay, so the first question is from the year 2020, 2021, June. And the first question is write an algorithm and draw the corresponding flow chart to check whether the given year is a leap year or not. So I won't really be drawing a flow chart, but this is really simple, but I'll definitely tell you the logic. So in order for a number to be a leap year, it must be divisible by 4, and we also should check if it's a century year or not. So it should be divisible by 100. In case if it is, then it should also be divisible by 400. So that is the condition we need to check. So if that condition is met, then that means that the year is leap year. So that's what you can use to, that's a logic you can use to draw the flow chart. Okay. The next one is write a C function is odd that accepts an integer arguments and returns 1 if the argument is odd and 0 otherwise. So we need to find out whether a number is odd or not. So we have to write function for that. So let's do that. So in the exam, you will be writing on the question answer sheet, and you'll just say include stdio.h, and then you'll create a function called int main, and inside of this, you can create another function, and you can call it is odd int num. Okay, so this function is basically going to have a name as is odd. The type of the variable is integer, and the name of the variable is num. And inside of this function, inside of the curly braces, we'll check a condition using if else statement. So using if, you'll say if num, and then you'll check if the remainder is not equal to 0. So a number is odd in case if the remainder is not equal to 0. So you use the modulus operator and then 2. So this basically is going to return what is the remainder of when that number is divided by 2. So let's say 4 is divided by 2, so remainder is 0. If 5 is divided by 2, then the remainder is 1. That's what it's going to return. So that return value will be compared against 0. So I'll say not equal to 0. As long as the remainder of the division by 2 is not equal to 0, then it's going to be a odd number. Okay, so I'll return 1. So if it returns 1, then it's going to be an odd number. Else, if it returns 0, then it's going to be an even number. Okay, so that is what it's asking you to do. Write a C function is odd that accepts an integer argument. So it is accepting the integer argument as num, and it returns 1 if the argument is odd and 0 otherwise. So it is returning 1 in case if the number is odd, 0 otherwise. So that's the answer for that question. Okay, next move up, move down. Write a C program that invokes this function to generate numbers between the given range. So we need to basically write a function that accepts a range. Let's say if I'm giving this function a range between 1 and 10, then it should print all the numbers between that range. So it should print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so how do we write that? So let's remove this. And inside of this main, first let's declare that function on top. So generate numbers in range, and it's going to accept 2 arguments. This function is going to accept 2 arguments. First is the range start, second is range end. So that's what this function is going to take. And then Inside of this, we can run a loop. You can say int I equals, so we'll start the loop from the range start number, and we'll go up until the end of that range end. So whatever that last number. So let's say this is 1 and this is 10. So I'll start from 1. So starting the loop from 1 and go up until the end of that number, which is 10 in this case. So we'll say range end. Okay. And then I plus plus is to increment the loop counter. So loop continues for that long. And then just print the number. So print f and percentage d, and in the bracket, sorry, in quotes, and then I. Right. And then we just call this number, call this function. Let's call it here. And let's pass 1 and 10 as the range. And let's see what happens. Okay, there you go. So you can see that it's printing all the numbers within that range. I think it's better to put at least a space in between, so at least it's clearly visible. Let's try that. Yeah, this looks much better. So what have we done? The question was asking us to basically write a C program that invokes a function. So it is invoking a function. You've written a function. This is invoking a function here. Generate numbers between a given range. So given range is what? Start from 1, go up until 10. So it's passing these arguments to this function. In this case, range start is 1, and then range end is 10, right? So it's passing that. So loop is starting from here. So let's say, for example, it starts from 1, go up until 10, and then because it's looping through, every time we are printing the value of the I. So I value is, in the first time the loop runs, the value of I is 1, second time 2, 3, and so on and so forth. Okay, so that's how it works. Right, let's move on to the next question. Define an array, and how do we declare and initialize a single dimensional array? Single dimensional array and two-dimensional array. Explain with an example each. So array is basically a collection of similar type of data stored in a contiguous memory location. Contiguous means continuous. So it's stored into the memory in a contiguous memory location. Okay. Okay, let's move on. How do we declare this and initialize a single dimensional array and a two-dimensional array? So single dimensional array is a collection of components or array elements that can be accessed individually by specifying the position of the element. Okay, so in single dimensional array we have the indexes like 0, 1, 2, 3, 4. Okay, and each item can be accessed by its index. So let me give you an example. So I'm going to remove this. So let me write the syntax. Syntax of a single dimensional array will be data type, whatever the data type is, integer, float, whatever that is. Array name, so name of the variable. And the array size, so how big the array should be, 5, 10, whatever that size is. Okay, so that's how you write the syntax. So let's write an array. So array will be int. Let's say the name of the array. So this is the data type, int. Name of the array, let's say it is n. And then what is the size of the array? Let's say there are 5 items in the array. Okay, so I'm going to put that there. That's how you define a single dimension array, right? Now, an array can be initialized in either of the two states. First is at compile time and second is at runtime. So at compile time, let's say, let me show you compiled time. Elements are initialized at the time of declaration, which means that the value is set at the time of declaration. So let's say you declare this another one, let's say nums. Let's name it as nums. We put the value. How do we put the value? We put that in curly braces, and we can say 1, 2, 3, 4, etc. Actually, 3 items, right? So 3 items. Okay, good. So that's how you initialize at the time of declaration. So this is declaration, like this is declaration, and then initializing at the same time. Okay, so that's how you go ahead and initialize an array at compile time. If you want to do it at runtime, then I can give you that example as well. Let me get rid of that. So that means the value will not be declared immediately. First, we go ahead and declare it. And then let's say we have a loop int I equals 0, I less than 3, I plus plus. We use scanf to take the input from the user. Percentage d and ni. Okay, so what this is going to do is that it's going to run this loop 3 times, and each time is going to ask for an input from the user. The user can enter any number, and it's going to store that value inside as the items of this array. Okay, so currently we have only declared it, we have not initialized it, we have not set any values. The values will be set at the runtime, which is at the time when the user gives the output. Okay, then we can just simply print it. So again, I'm just going to copy paste this loop and then just print it. So print f d nums I. Okay, let's try that. So first is asking for an input. Let's say I put 2, then 3, then 4. So now you can see that it's printed 2, 3, and 4. Probably we should give a space. Let's try again. So this loop is running 3 times. It's going to run 3 times. It's going to under each iteration is going to ask for a number. So we're going to put, let's say this time we put 4. Oops. We put 6, we put 7. And when I hit it, the program control will go to this loop and is going to print out all the items in the array, because that's how you access each item in the array by its index. So nums 0 is going to print 4, num 1 is going to print 6, and num 2 is going to print 7. So remember that the index starts from 0 and not from 1. So hit it. Oops, okay, 8. I refresh it. I shouldn't have done that. 7, 9. So you should print those 3 numbers. Compiler is behaving little weird. Yeah, there you go. 879 is printed that. Okay, all good. Let's go next. Now, it's also asking about the two-dimensional array. So we're done with a single dimensional array. Now two-dimensional array. So two-dimensional array is represented as a table of rows and columns. They are expressed as contiguous tabular block in the memory where the data can be stored in the table structure. They're also called matrices, or for a singular, it's just called matrix. Okay. So let me give you an example of a two-dimensional array. So I'm going to get rid of that. So the syntax of the two-dimensional array is, first is data type, second is the array name, then it takes the row size, and it takes the column size. Okay. So that's how it is declared. And let's take an example. So example. So first is the data type, right? So let's say the data type is integer, so int. Then it's the name of the particular array variable. So let's say we call it A. Then it's the size of the rows. So it's rows and columns. So basically, two-dimensional array is represented as a table of rows and columns. So rows, let's say they're going to be 2 rows. And column, let's say there are going to be 3 columns. Okay, so we put 3. And then we are going ahead and declaring it and we're going to initialize at the same time. So to initialize a two-dimensional array, we'll use curly brackets. Inside of this curly bracket, we use another curly bracket, and let's say for the row 1 column 1, in fact there are going to be two rows, right? So two curly braces, okay? And then inside of the first one is going to be the value of row 1 and column 1. So let's say it's going to be 1 comma, then row 1 column 2, it's going to be, let's say it's 2, row 1 column 3, let's say it's 3, and 4 and 5 and 6. Okay. All right. So that's how you go ahead and declare and initialize a multi-dimensional array, right? Now, the next question. Write a C program to implement string copy operation that copies a string str1 to another string str2. So by this, they mean create a variable called str1 which holds a string and copy the value of the str1 into str2. And that should be done without using a library function. So let's write a program for that. I'm going to get rid of that. Don't need it. And now, so we'll create two variables, and since they're going to be strings, the type of the data is going to be character. So it'll be char. And what are they saying? Saying name the first variable as string1. So let's do that. Oops, str1. And we also need to specify the size of it, because a string is basically a sequence of characters. Okay, so we need to specify the size. So let's say it's going to be 100. Then the second variable name is str2, which is this. So let's declare the second variable also. So str2 100 comma I, right? So that's going to be the declaration. And now we're going to print the string 1 after taking it from the user. So first we'll say print f. We'll basically take the input of that string from the user. We'll ask the user to enter the string 1. So we'll say enter string str1, and then in order for us to take the input from the user for the string, we'll use fgets because it's more safer compared to just gets. str1, so that's the name of the variable, which is this. And second parameter will be the size. So we can use size of function. Will automatically calculate the size of this particular variable by passing it here. And the last parameter is stdin library. Okay. And then next thing we're going to do is basically copy the string, like reverse it. So we'll loop through it and say for I equals 0, because we've already declared I on top. And str1, and since we'll be able to access each item, each character basically in that string, array string, we can access that by its index. So let's say I. We want to go up until the end of the string. And how it works is that the way we know that you are at the end of the string is by checking if the character is not equal to \0. Okay, so if we've reached the end of the string, the value of the character, which is what we're trying to access, is going to be \0. So that's what we're going to check. I'll say plus plus I, increment the iteration. And then we're just going to copy the str2. So copy str1 into str2. So each character. So str2. So what will be the each character? So in the first time the loop runs, the value of I will be 0. So that's why we'll use the index and we'll set it equal to str1 I. So what's going to happen is that this loop will go up until the end of the string, and each time during each of its iteration is going to get that character and is going to take the value of that character. Let's say, I've set Imran. So first time is going to be I. We'll paste that into the first index of this particular string, which we have declared on top. Second time we'll do it for M, then R, A, and then N until the end of the string. Okay. Now we also need to ensure, because it's going to be a string, we have to ensure that the last item in the new string variable is going to be this \0. Okay, so let's do that. str2 I 0 \0. Okay, then all we have to do is just print the str2, printf string str2, this copied string will be percentage. So it's going to replace the percentage value with the variable value, which is str2, and that's it. I think that should do the work. Let's just try it out. So hit it. Oops, something wrong. So you're getting an error like that. Let's see where we're going wrong. Size off, which is fine. Y equals 0. Undeclared str. Undeclared. Did you mean str2? Oh, sorry. Yeah, this is str2. str1 actually. Yep. Let's try that. Okay, perfect. Now I'm going to say Imran. Okay, why is it not showing? What's wrong here? str1. Okay, we'll come back to this one. It should ideally print that, but we'll come back to this one. Okay, let's go on to the next one. Write a C program to maintain a record. I think this is going to be really big, so we'll skip this one. The answer to this question should be on GitHub. I'll share the link later. Then we have discussed dynamic memory allocation in C. So what is dynamic memory allocation? Well, it is the process of calculating and allocating memory at runtime. Let's take an example. Let's say that there's an array of the size 9. Okay, so if there's a situation where less than 9 elements are needed, then the remaining indices are just waiting in the memory in this array. So there's a requirement to reduce the size of the array, reduce the length of the array. So this procedure of changing the size of the data structure during runtime is called dynamic memory allocation. So it allocates the memory dynamically. It's clear from the word itself that it allocates the memory dynamically as per needs. Now, it also asks you what is the dynamic allocation functions. Okay, so what are these? Well, there are four library functions provided by C, defined under stdlib.h. Okay, so I'm going to keep this open. We'll come back to it later. I'll open another one here. There are four library functions. First is, get rid of that. First one is malloc. Then we have calloc. Third one is free. And fourth one is realloc. Okay, so let's start with the first one, the first library function. So these are dynamic allocation functions which dynamically allocate the memory. So first one is malloc, which is basically memory allocation method. Okay, so what it does is it dynamically allocates a single large block of memory with a specified size. Okay, it returns the pointer of type void, which can be cast into a pointer of any form. So let me give you a syntax for that. So syntax will be ptr equals whatever the cast type is with an asterisk sign, and then malloc function, the function name, and the size of the byte, so byte size. That's the syntax for the malloc function. All right. So let me give an example. So let's say we declare a pointer called ptr, and we'll say int star pointer, and then we'll say pointer equals. So what is the first thing? The first thing says cast type, so it's going to be integer type. So we'll say int, then asterisk, then malloc function, and it says byte size. So let's say we want to give 5 into size of int. So size of function is a C library function which basically returns the size of the data type. So in this case int, so size of this will return 4. Okay, so the value of this will become 5 into 4 equals 20. Okay, so what this is going to do is this is going to basically generate a large 20 bytes block of memory dynamically, and dynamically allocate the memory for that, right? And that is basically what malloc functions do. It is whatever the size you've specified, in this case 20 bytes, is going to dynamically allocate the value of this pointer to be that size, which is 20 bytes. It will be one single large block of memory. Okay, so since the size of the integer is 4 multiplied by 5, that's 20 bytes dynamically allocated to ptr. So that's what your malloc is. Now let's go on to the calloc. Second one is calloc, also called contiguous. Contiguous means continuous allocation. Okay. So it is very similar to malloc. The difference is that it dynamically allocates a specified number of blocks of memory of a specified size. So what this will do is this will generate a single large block of 20 bytes, but in the case of calloc, it's going to divide that into multiple uh, single blocks. So instead of making single block of 20, it'll make 4 bytes each. So 4, so there'll be like 5 blocks total, and accumulatively it will still be 20 bytes, but it'll be individual 4 bytes. But here in this case it was single block of 20 bytes, but in the second case it's going to be 4 bytes each, so it'll be a total of 5 blocks instead of just a single block. So let me give you an example. Let me put the syntax first. So syntax ptr equals cast type, same as the above. Then asterisk sign. Then calloc n, and then the element size. Is the n is basically the number of blocks. Element size or byte size, whatever you want to say. Yeah, in this case, element size, right? Okay. Let's take an example. First, declare the pointer ptr, then set the value. We can also do it directly also, like you can say int asterisk ptr equals and then put it like that, but just doing it on a different line for now. So that's going to be int asterisk sign and then calloc function, and then inside of this we'll say 5, and then we'll say size of int. Notice here we were just taking the byte size in total, but here there's a comma separation. The first parameter is the number of blocks, and second one is the size of int. Here it was single large block. Here is going to be multiple 5 different blocks, each of size 4 because the size of int is 4. Okay, so that's how it's going to work. So total will be still be 20 bytes, but this time is going to be 5 blocks, each of 4 bytes. And on top, this was one large memory block of 20 bytes, right? That's the difference. Okay, let's go the third one, which is free. So what does free do? So this method basically is used to deallocate the memory that is being allocated using the functions malloc and calloc. So whatever memory is allocated by either of these functions, it's going to free that. And it's really good because it helps reduce the wastage of the memory by freeing up the memory. Okay. So it dynamically deallocates the memory. So let's take an example. So let's write the syntax first. Syntax is called free, then pointer, ATR. That's your syntax. Let's take an example. Example, we'll first declare the pointer int asterisk sign ptr, and then ptr equals int asterisk sign calloc, and then 5. So basically the same as what we did for calloc, which is this one, just kind of writing the same thing. Size of int, okay, and then so what this is going to do is this is going to go ahead and create 5 blocks of memory, right, of 4 bytes each. Correct? There's a spelling mistake there. Okay, so now we want to free that memory. So it's already allocated 5 blocks each of 4 bytes. So total 20 blocks, 20 bytes allocated dynamically using calloc. We want to free it, so we're going to use the free function. So how do we do that? So all we have to do is just below that we use free function, and then we pass the pointer for which we want to dynamically deallocate that memory. That's it. Okay, so what this is going to do is going to deallocate the memory allocated to PTR dynamically. Okay, so it's going to release that memory and make the space free. So that's all that free function does. Okay. Uh, the last but not the least is realloc. So can you make a guess, like what do you think realloc will do? As the name suggests, realloc means reallocation. So this method is used to reallocate the memory for a previously allocated memory. Okay. So in case if the memory allocated by, let's say, malloc or calloc is not sufficient, then in that case, we're going to use realloc to dynamically reallocate the memory previously allocated. Okay, so let me show that to you. So syntax ptr equals realloc. It takes two parameters, ptr and then new size. Again, I'm going to use malloc this time and just give an example. What does it do? It reallocates the memory of a previously allocated memory. So first we'll allocate it and then we'll reallocate it. So earlier we used calloc. Let's give it a try for malloc this time. Okay. So let's say I'll say int star ptr. So we declare a ptr variable. We set the value of the ptr variable to be type integer asterisk. Then malloc function, it takes single parameter, which is the byte size. If you remember, just takes the byte size. So we'll say 5 into size of int. Total will be 5 into 4, which is 20 bytes. Now we want to increase the size. So how do we do that? This is already allocated, right? 20 bytes is already allocated. 5 into 4 allocated. This is already allocated. I want to reallocate, which means give more space, more memory. So how do we do that? Well, all you have to do is just say ptr equals, which means the new value of the ptr becomes realloc. So we use this function, realloc. What does it take? It takes two parameters. First is the previously allocated pointer, so which is this one, ptr. And second parameter is basically the new size that you want to allocate. So earlier we allocated 20, but this time we're going to do it with, let's say 10 into size of int. How much that becomes? So 10 into 4, it's 40 bytes. Okay. So earlier, previously allocated size was 20 bytes, but because we have this function available, dynamically memory allocation function called realloc, it's going to take the previous pointer value and assign the new size, which means allocate the new size dynamically to be 40 bytes. So from 20, it becomes 40. Okay. So I hope that is clear. Let's move on to the next question. I have to make this person out first. Report. Reported him is out. And then we'll go to the next question now. Write and explain two preprocessor directives in C. Okay, so two preprocessor directives. First of all, let's understand what is a preprocessor. Well, it is a macro preprocessor that provides the ability for, let's say, inclusion of header files, macro expansions, conditional compilation, and line control. So basically, it is a text processing or substitution tool which filters your source code before it is compiled. So when it is not the part of the C compiler. So how does it implement? Well, it pre-processes the program before it is compiled. So it performs three tasks, which is removal of comment, expansion of macros, and expansion of include files. The C preprocessor is automatically used by the C compiler to transform the program before compilation. Then it returns the code to your compiler for compilation. Now it asks you what are the preprocessor directives, explain any two. So Preprocessor directives are basically lines in your code starting with hash, and they are followed by an identifier called directive name. So examples could be a hash include. So let's say if you go to this example, there's a hash include, right? So hash include is a preprocessor directive, this one. And this preprocessor directive is used to paste code of a given file into the current file. Okay, so there are different types of hash include preprocessor directives. One is hash include the file name. So in this case, if it's stdio .h, it's going to include that library. So it's used for including the header file. Search for files named by that in the list of the directories specified by you or followed by the standard list of system directories. Uh, if it's hash include file, it's used for including your own files also. So in this case, it's including the system library files, but you can also specify your own name of the file, and it's going to use that. And if you did that, you'll have to use the syntax something like this. So include and your file name. Okay. So it's used for the header files of your own program. And then hash include anything else, which means any includes directives whose argument does not fit in the above two forms is a computed include. Then we have hash if, which is also a preprocessor directive. This directive evaluates the expression or condition. If the condition is true, it executes the code. And if the condition is false, then it goes and exits out. So the syntax for this will be hash if and then your expression. And whatever code you want to write, you go ahead and write inside of that, and then use hash and if. Okay. Then there's something called macro expansion, which are basically small functions which does not add the overhead to the process, which is cost to the process. If we need to write a recursive function like repeatedly, so instead of using a function, we should rather use a macro. Okay. So an example would be hash define s1 1000. Okay. Example of a macro. Okay, let's move on. So write a C program to find the sum of the diagonal of the elements 3 by 3. So let's do that. So we've already read about the multi-dimensional or two-dimensional array, and that's what it's asking you to do. It wants you to find the sum of the diagonal elements of a 3 by 3 matrix. 3 by 3 matrix means 3 columns and 3 rows. So let's start. The first thing we're going to do is create an integer, call it as sum because we want to calculate a sum. Let's say initial value of this sum is 0. And then we'll also declare a matrix, a two-dimensional matrix, 3 columns and 3 rows. So 3 rows and 3 columns, we pass like that. And then we'll take the input from the user for each of these items in this particular array, two-dimensional array. So we'll say printf and enter matrix elements. Okay. And say n. And then we're going to loop through each of these items. So we'll say for int I equals 0. So for how long do we need to run the loop? So how many items are there? 3 items, right? So we'll run it for 3 rows. Then I plus plus increment. And inside of this, we'll also run another loop. So for int j equals 0, j, oops, j less than 3, and then j plus plus. Okay, inside of that. And we'll take those input from the user, print f, enter element a, percentage d, percentage d, I, and j. So what this is going to do is it'll run the first loop. The first time it's going, the value of I will be 0, j will be 0. So it'll get the first item, then it'll be 0. Next time is going to be 0, which is this, and then 1, then 0 and 2, 0 and 3. That's how it gets the first set of items. Then the loop changes to 1. So 1 0, 1 1, 1 2, 1 3. Then 2 0, 2 1, 2 3, like that. Okay. And then we'll say scanf. So we take the item from the user, percentage d, and so that the value of the variable gets modified, I, and then j. So row and column. Okay. And finally, we just need to print it. So say for, actually not print it, but calculate the sum. So let's say int k equals 0, k is less than 3, k plus plus. The sum equals sum plus a, k, and then k. Okay, so what we're trying to achieve is that we want the diagonal sum. Okay, so let's say if there was an array which was entered as 1 2 3, so 1 2 3 4 5 6 7 8 9. I'm going to comment this out so that it doesn't get executed. Let's say this was your two-dimensional array, 3 rows, so 1 2 and then 3, and 3 columns, which is this, this, and this. 3 rows and 3 columns. So we basically want the sum of the diagonal. So what is a diagonal? This is a diagonal, 159, right? Here. So what is the index of this element? So it's 0 0, 0 row, 0 column. That's how you access the value of 1. So notice what happens here. When you loop through it, first time the value of 0 will be 0. This will be 0 0, right? So we get the item 1. Next time it runs, this becomes 1. So you get 1 1. So what is 1 1? First row, first column. It's actually not first but second because the index starts from 0. So 0 1. So this column and this row. So that's how you get the value of 5. Next time it runs, this becomes 2. So what is 2 2? So 2 is this and this, right? So that becomes 9. So it's something like this. First iteration will be 0 0, which is basically equal to 1. Second iteration going to become 1 1. That becomes 5. Element right here. And the last iteration is going to become 2 2, which is 0 1 2, which is this row, this row. Sorry, 0 1 2 is this row, and column, which is this 0 1 2, which is this. Okay, so comes to equal to 9. So what's the total of that? 9 plus 5 plus 1 is actually 15. So ideally, I should get an answer as 15. Okay. Finally, we just need to go ahead and print the sum. So we'll say print f sum is percentage d and then sum. Okay, so let's try it. You all good? Let me remove the hello world. We don't need that. Done it. So it's asking you, okay, I think we should add a colon and a space. Let's try that. Yeah, good. So enter the element A00. So what is A00? Here, take a look. A00 is 1. So let's enter 1. I mean, you can give any number. I'm just going by this example, so at least we are clear what's happening. A01. So what is A01? A01 is 0 row, but column 1. Okay, so column is 1 and row is 0. So column is 1, row is 0. Row is 0 means first row, so it's 2. So let's enter that. Similarly, we'll enter the next one. Come on, what happened? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. See what happened. We entered all these values. I've already shown you how you calculate. This is row, this is column, row, column, row, column, row, column, all of that. Okay. So you entered all these values, and notice we get the sum as 5, which is exactly what we were expecting. Okay. So that's what this question is asking you. This question is asking you that write a C program to find the sum of the diagonal elements of a 3 by 3 matrix. It is a 3 by 3 matrix. So it's 3 rows, 1, 2, 3, and 3 columns, which is 1, 2, 3. And then we just loop through it, and we want the diagonal, which is 159 sum, and that's what you've got, which is 15, and that's perfect. Okay. Now let's go on to the next question. Okay, this person came again. Report. How to get rid of that. Okay. Let's move on. Now, using recursion, write a C program to find the factorial of a given number. So, I'm going to refresh. So, what is factorial? Well, n factorial is basically product of all the consecutive integers from 1 to n. So, let me write that down. So, n factorial, which is n factorial, is the product of all the consecutive numbers or integers from 1 to n. Okay. So let's take an example. Take an example. Let's say n1, n factorial, not n1, but n factorial equals n. So that's a syntax. So it should be syntax, not example. N factorial, that's a symbol of factorial, n not, okay, is n into n minus 1 into n minus 2 into n minus 3 and up until 1. So as long as it doesn't reaches the value 1, this will be continue to reduce that. So let's say an example would be 4 factorial. Let's say if the number was given as 4, it'll be 4 into, so what is n minus, so the value of n is 4. So n minus 1 means 4 minus 1, 3. 3 minus 1, 3 minus 2. Sorry, n minus 2, which is 4 minus 2, is actually 2. 4 minus 3 is 1. So it goes up until 1. Okay, so that's what that program is expecting. It's expecting that if a number 4 is passed, it should calculate the factorial of that, multiply all these numbers using this formula and return the total value. Okay. So how do we do that? First thing we're going to do is we'll create a function, a long int. So that is going to be the data type long int, multiply numbers, because numbers can be really long. That's why we are saying long int. Like the total value can be really long. It's going to take an integer, let's say n. If n is greater than equal to 1, then return n into multiply numbers n minus 1, else return 1. Okay. So long int multiply numbers, int n is greater than equal to 1, and return n into multiply numbers n minus 1, else return 1. Okay, so that's the formula. So what is it actually doing? It's called a recursive call. Remember we spoke about macros and stuff where we were doing recursive calls. This is a recursive call to the function. What we're doing is, if this function is called, pass the value, is going to check for as long as the number is greater than or equal to 1, go ahead and call this function again by multiplying the previous returned value. Okay, and each time you recursively call this function, which means call the function again. So recursive function is, in this case, a function is calling itself. Okay, so each time it's going to decrement the original value it received as the value returned by that function. So first time, if it received 4 as a value, it will say 4 multiplied by whatever this function returns. So this is going to be passed as 4 minus 1, which is 3. So next time 3 will be passed, another call 2 will be passed, then last time it's going to be 1, because it says for as long as the number value is greater than or equal to 1. When it becomes 0, then of course it's just going to be returned as 1. Okay, so that's that. Now we'll go into the main function, and here we'll say print f, enter a positive integer. So it's going to return, we're going to take an input from the user as an integer. So the scanf, I think we should also declare it on top. So int n, and it's going to be d for digit, type, and n. So we're going to take that number from the user, then print f, I'll say factorial of percentage t number, or we can just say factorial d equals to percentage ld means long integer. Okay, so then we'll say n. So this value will be replaced by whatever the number the user enters over here, and the second parameter will be the value of the multiplication. So for getting the value, we'll just call this function that we have declared on top, but we'll pass the value that's been entered by the user, which is n. Okay, so let's see. I'm going to run this function, enter positive integer. So remember, we want to do for 4. So we'll say 4. So what do you think we should get? 4 multiplied by 3 multiplied by 2 multiplied by 1. So 4th is a 12, 12 is a 24. So you should get 24, right? 24 into 1 is 24. Oops. What's happening? Yeah, there you go. So factorial of 4 is 24. So how did that work? Here we say enter positive integer, which is at this point. Using scanf, we stored the value of what the user, which means I, entered over here as 4 into the variable n. At this point, it's printing this value, saying back factorial of what 4, because 4 value was stored here inside of n. So this d is replaced by the value n, and then whatever the total comes is returned by this function. So what is function doing? Passing 4 in this case, right? Because we entered 4. When 4 goes over here, is it checking? The first iteration is checking. Is 4 greater than or equal to 1? Yes, it is. So do this. So in the first iteration is going to do, it received 4. Going to multiply that. What is going to do? Again, call this function. So it's going to become 4 minus 1, which is 3. So 3 will be passed to this. Let's come back here. And this time I'll say 3. So it becomes 3. And so on and so forth. So you'll keep multiplying that up until the value becomes 1. Okay. Right. So initially multiply number is called from the main with the 4 as an argument. 4 is passed to multiply numbers from the same function. Each recursive call, the value of the argument is decreased by 1. If the value is less than 1, there's no recursive call because it's not calling this function again. So loop, so this thing breaks, it goes here, and finally it's just going to go ahead and return the total value, which was 4 multiplied by 3 multiplied by 2 multiplied by 1, which becomes 24. Okay, perfect. So we have done up until 3 questions, and I think we should take a break, and we'll come back again in the next episode, and we will discuss it further very soon. All right. Thank you very much, guys. Bye bye.